Hello, my name is Rob Reynolds. Welcome to Math-073. Today we're looking at section 6.7 and we're going to get some word problems, applied problems, using the Pythagorean theorem, a squared plus b squared equals c squared. So there's many different types of problems that deal with powers and taking square roots, and the Pythagorean theorem is probably one of the most common that you learn in geometry, and it basically says a leg squared plus another leg squared is equal to the hypotenuse, which is always the side opposite the right angle, and it's also the longest side, c squared. So c is the longest, and it doesn't really matter which order that you put these two legs in. So the first example that we have, it says, how long is a guy wire which reaches the top of a pole? So if I draw a pole, this is probably the guide wire here. And how long is that is probably what we're trying to find here. It's given that the pole is 14 feet high, and it's also given that it is assumed that it's right, but it's also given that it's 8 feet from the pole. So this guide wire's 8 feet from the pole, which starts down here at the ground. So we'll do the Pythagorean theorem, a squared plus b squared equals c squared. And again, it doesn't matter if you use 8 and 14 or 14 here. Either one would work. And I'll just simplify. You may know that 14 squared is 196. We'll add that to the 64 to get 260. And I would probably take my calculator and take the square root of 260. You could try to simplify this, but I think we're probably looking for decimal answers here. They'll probably make a little bit more sense, so I would go to 16.125. There are some cases where I would try to simplify this by pulling out maybe a 4 and a 65, and simplifying this to 2 squared is 65, which, by the way, might even reduce to more, but I don't even really care about the exact answer. It's probably an estimate when you're dealing with word problems. Makes the most sense. Let's try this again. A squared plus b squared equals c squared. So 144 plus 256 is equal to c squared. So if I add this up, 400, and I think we know 20 times 20 is 400. So I would say 20 is the hypotenuse length. Here we go. Be careful. This is the first example where we're given the hypotenuse. So I will say a squared plus b squared equals c squared. This time we're actually given the c value, which is the longest. So we want to make sure that we don't plug these numbers in incorrectly. So I'll assume that we've got an a squared plus the b squared is the value that I do not know this time. So again, I'll get 400 b squared. But this time I'm solving for a leg. So I will want to subtract off 400. And again, I'll take the square root of that and probably give a decimal equivalence, which I think you should practice typing that in and making sure you get 13.26. It makes a little bit more sense. When you're telling someone the length of something, no one would say the square root of 176. They would say about 13.3 feet or however long. So sometimes the hard part is, again, setting these problems up. This looks similar to before. I still have a guide wire, so it looks like I have that same kind of triangle. How long will the guide wire must be? So C is what I'm trying to find again. The telephone pole is 15. Boy, this one sure looks like the first problem that I had worked. 10 squared plus 15 squared is equal to c squared. So this is 100 plus 225 is 325, and the square root of 325 I'd probably leave as my final answer in decimal form. Let's see if the book follows. And yes, they do. Whoops, there it is, 18. So the square root of 325. That's interesting that they did that, but yeah, we would have gotten the same thing. Oh, I see what they did. That was their check. Here they took the square root of 325, so their final answer is 18.028, but they're just saying, hey, when you go back and check this, be careful. You may not get the exact answer, and it's just because of a rounding error that they had used. So yeah, I would stick with the green answer, 18.028. Reading this problem, the first thing I see is a plumb line is dropped, and that's going to go straight down to the bottom. Oh, and they tell me that it's 71 feet, so I'll label that 71, and I assume that's going to create a right angle down here. The next thing I read is this 100, is the sides. So each side, this yellow distance must be the length. Each side of the quadrilateral triangles measures 100 feet. How far is, so how far is it from this green distance or this white distance? So I'll pop out this triangle in here, which I think we've created. And let's label this triangle. We know this is 71. We know that each side is 100, and I'm trying to find, we'll call this A. So I will use my formula, a squared plus 71 squared equals 100 squared. A squared plus 5041 is equal to 10,000. A squared is 4959, and I would use my calculator to calculate the square root of 4959, and then I would check for the reasonableness of the answer. If I ended up with something like 10,000, that doesn't quite make sense in my scenario. I would know I would immediately did something wrong, but if you take the square root of it, it looks like we get somewhere around 70.4. So sometimes setting up the triangle is the hardest part in reading it. So let me give you the last example here, where sometimes we have to set up two different problems. The length and the width of a rectangle, so I'll draw a rectangle, are given by consecutive integers. And consecutive integers means, well, like 4 and 5 are consecutive, or 9 and 10 are consecutive. So if this is x, this is going to be x plus 1. So that's the length is maybe x, and then the width is going to be then x plus 1, or vice versa, it doesn't matter. But they do tell me that the area of the rectangle, so I know that area is length times width, or in this case, the area is x times x plus 1. And they tell me that the area is 90, so I'll fill that in. 90 is equal to x squared plus x. I can set this equal to 0 and actually start solving for an x value. X squared plus x minus 90, and I'm going to look for factors of 90 that differ by 1. Well, I can use a 10 and a 9. Signs are going to be different. Larger term is positive. Now, this is interesting because if this is a real-world problem, negative 10 for a distance of a rectangle does not make any sense. So we talked about extraneous solutions last video, so I'll say we'll throw that out. And if x is 9, then that makes this 9 plus 1, which is a whopping 10. But we're not done, because the real question says find the length of the diagonal of the rectangle. Well, I haven't even drawn the diagonal in. The diagonal is here in yellow. And again, I'll pop out a triangle. This black triangle is what I'll be working with, and I finally have some sides of that triangle. I found out that this is 9 and 10, and they say find this length. So I'll go back to my Pythagorean theorem. So a couple formulas here. A squared plus b squared equals c squared. 81 plus 100 is 181, and I'll take the square root of 181. And I suppose it's somewhere around 13. I would use my calculator. Let's see if the author agrees. So here they're discussing that we can't have a negative 10. Here they finally got the rectangle. They plug it into the formula, and there it is, 13.454. I hope you found this video helpful. If you have any questions, feel free to email me. Thanks.